Hello all, I am KIRITHIKA and I am with my teammate ASHMITH and we are from SRM Institute of Science and Technology from the Department of Computer Science and Engineering Emerging Technologies. And today we are here to talk about the ARM processor. So what is ARM processor? ARM stands for Advanced RISC. An ARM processor is a central processing unit that uses a RISC architecture. Now the full form of RISC is Reduced Instruction Set Computer. ARM processors are known for their high performance and energy efficiency. Next, let's talk about the data sizes. ARM processor registers are 32 bits in size. Now, the first data type is byte, which consists of 8 bits. That is, the size of the byte data type is 8 bits. And the size of word data type is 32. The size of the word data type is same as the size of the ARM processor. Keeping this in mind, we can estimate the size of the half word and double word data type. The size of the half word data type is half the size of the word data type, that is 16 bits, and the size of the double word data type is double the size of the word data type, that is 64 bits. Now next comes the instruction sets. ARM instruction set is a collection of machine language commands that the ARM processor can execute directly. And there are different types of ARM instruction sets. Those are 32-bit ARM instruction set and 16-bit thumb instruction set. 16-bit thumb instruction set uses lesser space compared to the 32-bit ARM instruction set. Now the key components of an ARM instruction set are data processing instructions, load and store instructions, control flow instructions, and special instructions. Let's understand each of them. Data processing instructions. These instructions perform calculation on data or they manipulate data. Now this add instruction set adds two numbers together. Sub instruction set subtracts one number from the other, and the logical operators like the AND, OR, and NOT will perform the logical operations on binary data, and they operate this binary data bitwise. Next comes the load and store instructions. These instructions handle data movement between the CPU and memory. So the load instruction set moves the data from the memory to a CPU register, and the CPU register is the temporary storage present inside the CPU. And the store instruction set moves the data from the register back to the memory. Next comes the control flow instructions. The control flow instructions consist of branch with link, and compare. Set jumps to different part of the program, and the branch with link is also similar to the branch instruction set, but the difference is that it saves the return address of the previous instruction, and this is often used for function call. Next comes the compare instruction set, which compares the two values, and based on the comparison it sets the flag. So these flags are used for the conditional execution. Particular decision is taken based on the value of the flag. Next comes the special instructions. These include instructions for specific operations such as interrupts and system control. Now if you take the case of interrupts help in handling events like a hardware signal, like a keyboard interrupt. So whenever there's a keyboard interrupt, the interrupt request is being served first. Next comes the system control. Now system control consists of instructions that manage between CPU states, that is switching from the user to the privilege mode and vice versa. Next comes the processor modes. The processor modes in ARM dictate the state the processor is in and what it is currently able to do. And there are different modes designed for the ARM processor, and those processor modes are being used for different operations. Now the advantage of having these processor modes is that it provides security and flexibility. Now there are 7 processor modes in ARM processor, and they are user mode, FIQ mode, IRQ mode, supervisor mode, abort mode, undefined mode, and system mode. Now the first mode is the user mode. This is a very basic mode of the processor, and when ARM processor is present in this mode, it has very limited access. Next comes the FIQ mode. FIQ mode is also known as fast interrupt request mode, and this is a special mode used for handling requests. Now when the ARM processor is in fast interrupt request mode, what happens is that it serves the interrupt requests which are of high priority. Next comes the IRQ mode. IRQ mode is also known as interrupt request mode. This type of mode is similar to FIQ mode, but it is used when low priority requests come in. Next comes the supervisor mode. So our processor enters into supervisor mode when it needs to perform secure or sensitive operation. and this type of mode is commonly used for handling system calls in operating systems. Next comes the abort mode. So ARM processor enters into abort mode when there is a failed attempt to access invalid memory. This mode helps the processor to manage errors without crashing the entire system. Next comes the undefined mode. ARM processor enters into undefined mode when the processor encounters an instruction it doesn't recognize or cannot execute. So this mode will allow the system to handle unknown instructions gracefully. And the last mode is the system mode. System mode provides more privileges than the user mode. And this type of mode is used by the operating system to perform system level tasks that need full access to hardware resources.
Hello, I'm ASHMITH here to talk about ARM register sets and exception handling. ARM exception handling. Exception handling in ARM processors allows for special processing during events like interrupts. ARM processors use a structured approach to handle exceptions, which are essential for managing interrupts. CPSR is copied into a mode-specific state program status register. What this means is the CPSR is copied into a saved program register during an exception. Bits in CPSR are set to switch to the ARM state, which enter exception mode and disable interrupts. The return address is saved to a link register, and program counter jumps to the vector address to handle the exception. So all of this enables the temporarily shift focus from regular tasks to handle more necessary or important tasks. So the purpose of program status is to contain flags and control bits that reflect the process status. So the key components of PSRs include N, Z, C, and V, which indicate ALU results like negative, zero, carry, and overflow. Q flag shows an operation resulted in saturation. Interrupt disable bits are I and F, which disable different interrupt types. T bit switches between ARM and thumb states, controlling instruction sets. These registers help the processor make decisions based on current operation results and status. So, all ARM processors have 37 registers categorized for different purposes. Different components of the register set include general purpose registers, which are R0 to R15, a dedicated program counter, PC, CPSR, and 5 SPSRs for various modes. The processor mode determines which registers are accessible, allowing for efficient handling of tasks in various operating modes. ARM supports different modes to prioritize certain registers depending on operation needs. User mode is for general purpose access. FIQ mode offers extra registers for fast interrupt tasks. IRQ and supervisor modes. These modes are used for interrupt handling and system functions. Optimized access for specific tasks. What this means is that each mode ensures efficient processing by granting access to registers necessary for those specific operations. Certain registers are only accessible in privileged modes. Special registers R13 and R14 have separate versions of these registers. Stack pointer and link register, to name them, are available for modes like FIQ and SVC. SPRs are accessible only in privileged mode. The purpose of bank registers is to enhance security and prioritization, reserving resources for critical tasks.
Thank
Thank you.
you.